told you that 197, we have to check the pairs of 197. So 1 to 14, 1 to 14 was this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We have to check that whether 197 has a factor between 1 to 14. So in order to check it, 197 is an odd number, and an odd number cannot be divisible by an even number. So obviously all the even numbers will be cancelled out. So there is no need to check all the even numbers from 1 to 14. So 2, 4, 6, 8, 10, 12, 14 are eliminated. After that, obviously, we have to check for 3, 5, 7, 9, 11 and 13. So how many numbers are left? 3, 5, 7, 9, 11 and 13. So we have to check that whether this number 197 is divisible by any of these numbers. Now let us see that how many of these numbers are prime and how many of these numbers are composite. We can see 3 is prime, 7 is prime, 5 is prime, 11 is prime, 13 is prime. 9 is not prime. 9 is a composite number. So now my question is that if a number is divisible by 9, then that number will also be divisible by 3. So if that number is divisible by 3, then obviously that number is not a prime number. Here in this whole setup, my objective is to find out that whether a number is prime or not. This is my sole objective. So I have to find a factor except 1 and that original number of the number. This is my only objective. Now, in case of 197, from 1 to 14, I eliminated all the even numbers. So only odd numbers were left. 3, 5, 7, 9, 11 and 13. In these 3, 5, 7, 9, 11 and 13, 9 is a composite number. Now, my logic is that there is no need to check the divisibility of this number 197 by 9. Because if this number 197 is divisible by 9, it will also be divisible by 3. So there is no need to check it by 9, just check it by 3 only. And after eliminating 9, you will see that 3, 5, 7, 11 and 13 are left only. The point here to understand in the chapters of number is that even the composite numbers are formed by the constituent prime numbers. That is, which quantities are the composite numbers made of? The composite numbers are made of prime numbers. That means that any number which has more than one prime, obviously it will be a composite number. 3 into 5. 3 and 5 are separately a prime number, but when we multiply 3 and 5 in 15, then it becomes a composite number. So obviously 9 is the composite number here, and 9, this composite number is made of prime numbers only. So we have to remove the composite numbers and check with the prime numbers only. This is the logic. The logic is that if this number 197 is divisible by 9, then this number 197 will also be divisible by 3. This is my logic. So if you have to check the divisibility by a composite number, if all the primes of those composites are considered in the foray, then you can check by those primes only, and there is no need to check by that composite. I will take one more example of this thing. Maybe this thing is not a bit clear to you, but I will tell you once again. You can say a big number. That big number concept will be more clear to you. Suppose I take a number 413. I have to check that whether this number 413 is a prime number or not. Then the very first case, I will calculate the under root. What is the under root? 20 square is equals to 400. 21 square is equals to 441. So obviously it will be between 21 and 20. So somewhere around 20 point something. Now that logic of factor pairs says that if this number 413 is divisible by some number except 1 and 413, then that factor pair will have one number less than 20 point something, and the other number of that factor pair will be greater than 20 point something and less than 413. So the range would be 1 to 20 point something to 413. If we are able to find a number in this range, we will easily be able to find a number in this range corresponding to this number. This is the logic of factor pairs. So I will going to write down every number from 1 to 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So in this number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. You have to find out that whether there is a factor of 413 in these numbers. Obviously, this one is a factor. We know this thing. So we don't need to consider this one. We just need to consider the other things. So in that case, what we are going to do? 2, 4, 6. This number 413 is an odd number. Then obviously this number 413 cannot be divided by an even number. So even numbers have to go. 2, 4, 6, 8, 10, 12, 14, 16, 20 and 80 are gone. So now we have to check the divisibility of 413 by remaining numbers. Which numbers are remaining? 3, 5, 7, 9, 11, 13, 15, 17, 19. Now let's see of the remaining numbers how many are prime. 3 is prime, 5 is prime, 7 is prime, 9 is not prime, 11 is prime, 13 is prime, 15 is prime, 15 is not prime, 17 is prime, 19 is prime. So 15, one composite number, 9, second composite number. Now 413 is divisible by 15. We don't need to check it, because if this number is divisible by 15, then it will be also divisible by the factors of 15. And what are the factors of 15? 5 and 3. 5 and 3. So obviously we don't need to check this number divisibility number by 15. We have to just check that whether this number 413 is prime or not. So 413, there is no need to check it with 15, because if it is divisible by 15, it will be also divisible by 5 and it will be also divisible by 3. So it is not necessary to check it by 15. So 15 is eliminated. And for the 9, it is the same reason. 9 is comprised of 2 3s, 3 square. So if this number 413 is divisible by 9, then this will also be divisible by 3. So there is no need to check it by 9. Then how many numbers are left? 3, 5, 7, 11, 13, 17 and 19 and all are prime. So this is my whole logic. If you have to check that whether a number is prime or not, you find out the square root of that number and check all those numbers that are less than that number and are prime. That is, we have to do just this. We have to calculate the under root of 413, 20 point something will come. We have to jot down all the numbers, all the prime numbers which are less than 20. And from those prime numbers, we have to check the divisibility of 413. And if any prime number divides 413, then 413 is not a prime number. And if it is not able to divide, then obviously 413 is a prime number. So this is the reason. If any prime number less than 20 is not able to divide 413, then 413 is a prime number. And if it is able to divide 413, then 413 is not a prime number. This is the whole logic beyond this thing. The theory of factor pairs should be clear to you. Maybe in the first time it is not clear to you, because it is a bit difficult to understand the theory of factor pairs. I will once again speak this to you one more time, just to make it clear. I will write it also. You just jot it down. I will try to explain it once more to you, because I know that this concept is a very difficult concept and it is very difficult to understand it by yourself. But I am here to help you in all possible helps. Even if after this video you are not able to understand that what this concept is, you leave your comments in the comment section. And I will, below the video there are comments, you can post it there and I will respond to your comments as soon as possible for me. I will do every sort of help to you for your examination purposes, and I will upload every sort of video. And before CAT 2014, I will upload all the videos related to maths concepts, reasoning concepts. It will take me around time of 2 to 3 or maybe 4 months. It is going on right now, it is March, April, May, June. At the end of July, you will get all the videos. And in spite of that, you will have ample time. And if possible, there are few friends of mine, there are few colleagues of mine who have taught in Time for Education and Scalar Launcher English. If possible, I will ask to them that whether they are interested in making English videos. If they are interested, I will upload them also. But I am not promising that thing to you. I am promising only quantitative aptitude and reasoning videos for you. English is totally conditional. If they will say yes, then I will upload the videos. If they will not say yes, I am sorry for that. Now, once again, the concept of factor pairs. What did factor pairs said? Suppose I will take it in a different number, 80. How can we write 80? 1 into 80, 2 into 40, 4 into 20, 5 into 16, 8 into 10. These are the factor pairs. Now, if we calculate the under root of 80, what will be it? It will be somewhere around 8 point something. Because 9 square is equals to 81 and 8 square is equals to 60. So we have to check. We will see that 8 point something. This 1 into 80. 1 and 80 are its factors, but 2 and 40. In this 2 and 40, 2 is less than 8 point something and 40 is greater than 8 point something. In this 4 into 20, 4 is less than 8 point something and 20 is greater than 8 point something. 5 into 16, 5 is less than 8 point something, 16 is greater than 8 point something. And 8 into 10, 8 is greater than, 8 is less than 8 point something and 10 is greater than 8 point something. So this denies that in the factor pair of a number, one number of that factor pair is less than the square root of that number and one number of the factor pair is greater than the square root of number. So in order to find out whether a number is prime or not, you just need to find a factor from 1 to under root of that number. And if you find a factor in that range, obviously there will be a factor in the range of under root to that original number. So, but it is advisable to use the range of 1 to under root of that number because that is easier to do. In comparison, to find a number in the range of under root to the original number, it is better to use the range of 1 to the under root. And if you are able to find a number in that range, obviously that number will not be a prime number. So this was the whole theory that whether a number is prime or not. I hope you liked this video, and in the next videos I will upload more concepts for you. Now most probably I will be dealing with either with divisibility rules or LCM or HCF. Most probably I will tell you LCM or HCF. LCM is a very basic thing, you all know, but the type of questions that you are going to encounter in your examinations, that I will tell you of LCM also, of HCF also. After that, the basic concepts of remainders and then divisibility rules, because in order to understand you or explain you divisibility rules, the basics of remainders should be understandable to you, and the rest of the videos will be uploaded soon. So thank you for watching the video.